All right, welcome to Wednesday. Go ahead and get out your homework. Let's grade this thing. So we had 2 through 22 evens. Page 411. Here we go. So remember, these are odds. Number 2, 1 to 5. That's 1 TO 5. 1 to 5. Number 4, 1 to 1. Number 6, 2 to 1. Number 8, 3 to 1. Number 10, 7 to 3. Number 12, 1 to 1. Number 14, 3 to 1. Number 16, 4 to 1. All right, so 18 through 22 we're dealing with you're rolling 2 dice, right? And just remember, there are 36. There's always 36 possible things that can happen when you roll dice. So you probably even I'll certainly put one on the semester final where you're rolling 2 dice. So just remember, it's 36 total things that can happen when you roll a pair of dice. Number 18 is 17 to 1. 17 to 1. Number 20 is also 17 to 1. Number 22 is 13 to 5. 13 to 5. There you go. All right, count out how many you got it wrong and answer question 1 in the Google Forms. All right, we made it. Last week of learning new stuff. Just 2 lessons, today and Friday. This is all probability stuff. So the math is relatively easy. However, there's some formulas involved. Make sure you understand the formulas. Next week, we'll do semester reviews. I'll do 2 days. We'll review everything that we learned from January onward. So from January all the way up till Friday, right? That material will be on the test. So here's your final schedule right here. You can see this. Next week on Friday, you're going to take your first one, your English final. It'll be the only thing you do that day. So just 1 test. That's it. That's the whole. You'll take attendance, obviously, and then take your final. We got a 3-day weekend. Memorial Day, come back when we finish our finals. There's 4 days of finals. It goes science, Latin, math, and history. Once again, 1 final per day. So we're going to review for the math final, right, next week, but we're not going to take the test until that following week, the 3 weeks from now, Thursday. So that's a long time between the reviews and the test. So make sure that, I'm not going to close down the Google form or anything like that. You'll be able to review, watch the video as much as you need. It's going to be your standard multiple choice test for me, but it will cover everything from January onward. All right, here is your homework for tonight. Please copy that down. Okay, so here's where I start losing some students. It's not because the math becomes much, much harder. It's simply because we start calling these things of probability with different names, and we get some different formulas. Now, we're only going to do 2 days of this, today and Friday, so we're not going to finish the chapter. So there's lots more formulas involved with probability. You're only going to see 2 of them. All right, and one of them is something called a mutually exclusive event. All right, so we're going to go back to probabilities. Not that we're going to completely blow off odds, right? It will be on the semester final, but everything for today and for Friday will be dealing with this concept of probability again. And remember, probability is the chance of an event occurring. Remember, outcome is all the possible things that can happen when you play the game. Events are one or more of those outcomes, and the probability of event we define as the fraction or the ratio, the number of favorable outcomes over total outcomes. Remember, this is different than odds. Odds is the number of ways to win over the number of ways to lose. So this one is how many favorable outcomes, in other words, how many ways to win, not over how many ways to lose, but everything that can happen. Okay, so back to probability. So for the next 2 classes, right, I say few classes here because there's actually, I think, 4 lessons on this. We're only going to do 2 of them. So for the next 2 classes, we're going to be dealing with 2 specific types of probability, or 2 specific types of events. The first event, the one that we're doing today, is where we're going to be talking about events, plural, events where they cannot happen at the same time. It's impossible. 2 or more things that cannot happen at the same time. And then on Friday, we're going to talk about 2 or more events that can happen at the same time. So let's try to wrap our heads around this. Well, first, I'm going to give you a word and a definition for the first one, and on Friday for the second. So for the events that cannot happen at the same time, we're mathematicians, of course. We got to give them a name to that, and we're going to call these mutually exclusive events. These are events that cannot happen at the same time. Now, we're going to restrict ourselves, at least for this year, to one game, one turn. Meaning we're going to play just one type of game, and we're only going to take one turn. Okay? Now, we can do this differently, but for our book, this is how they introduce you to this idea of mutually exclusive events. One game and one turn. All right, mutually exclusive events are events that cannot happen at the same time. Well, what would be an example of one game taking one turn of two or more events that cannot happen at the same time? So here's an example. We're going to roll one die. Okay, so remember, number cube has numbers 1 through 3, 4, 5, 6. So what is the probability of rolling a 4 or a 6 with one die? Now remember, the game is one die, one roll. One die, one roll. So can you roll a 4 or a 6? I mean, can you literally roll a 4 or a 6? You can't roll both. You can roll one or the other. This is a mutually exclusive event. Here's another example. You got a deck of cards. What's the probability of choosing an ace of spades or a king of hearts? Right? If you're only drawing one card, it can't be both. These are two events that could occur, but they simply can't occur in one game in one turn. So both can't happen. Both can't happen. So today, these are the ones that we're going to be calculating the probability for. So I understand that in totality, when we talk about the entire chapter, it's easy to confuse these words. For my recommendation for students is always write down a good example. Right? This particular one, here's two great examples of two events that can occur, but they just can't happen in the same turn. Okay? All right. So what would be some non-examples, right? In one game, in one turn, these are going to be events that could happen at the same time. So back to the rolling one die, what's the probability of rolling a 4 or a number greater than 2, right? Well, let's see. Could these happen at the same time? Sure, a 4 is both 4 and greater than 2, so both of these could happen at the same time. All right, now if I roll a 3, well, that's greater than 2, but it's not a 4, right? But however, I can meet both of these requirements to be the number 4 and to be greater than 2 in one roll. So these are some non-examples. These are not mutually exclusive. Here's another example, back to cards. What's the probability of choosing a king of hearts or a red card? Well, the king of hearts is red. Therefore, you met both requirements. These things can happen in one game in one turn. I didn't change my slides, so bear with me here. We will not do this tomorrow, but we will do this on Friday. Okay? So today we're going to be doing the ones that cannot happen. These are going to be mutually exclusive events that cannot happen at the same time. All right, so hopefully you understood that. If not, rewind, listen to it again. Okay? Now it does have a formula, right? It won't be the standard probability formula. It'll be a new one. So here we go. Write this down, please. This is the formula. Now we're gonna simply restrict ourselves to just two events, but I do want you to understand that this could be 3 or 4 or 5 events. But we're just gonna say 2 events. So the probability of either A or B, if they are mutually exclusive, meaning they cannot happen at the same time, then the way you calculate that is, well, you calculate the probability of A occurring, and you add that to the probability of B occurring. Does that make sense? So the formula there, probability of A or B, is equal to the probability of A plus the probability of B. Remember, that doesn't mean P times A plus P times B. That means P for probability. Notice it's also italicized there. So probability of A plus the probability of B. All right, as always, half the time this makes much more sense when we do an example. So let's do an example. So we're going to play the spinning game. One turn, one game. Spinning game. Why do I keep saying one game, one turn? Because there's other probabilities where you do multiple games, one turn, or one game and multiple turns. All right, so our example here is going to be on mutually exclusive events. So we need a mutually exclusive event. So how about the probability of spinning a red or an even number? Well, notice red has the number 7. 7 is not even. So you can't be red and even at the same time, right? I can either be red, or I can be even, or I can be neither, right? But I can't be both at the same time. So these are mutually exclusive events. All right, mutually exclusive events. So there's my formula. It says to find the probability of A or B, find the probability of A and add it to the probability of B. So what are A and B? A and B would be the two events. So read it again. The probability of spinning a red or an even number. Now I'm going to make this far more complicated than it needs to be. I'm going to write out the words. A now stands for red and B now stands for even. So the probability of red or even is equal to the probability of red plus the probability of even. Okay, that makes sense? Okay, so now we got to do each one individually. What's the probability of red? Remember, probability is defined as how many ways to win over everything that could occur. If you spin this, how many things can occur, right? How many things can occur? Well, there's 8 numbers, so there's 8 things that can happen. How many of them are red? Just 1, so that means 1 way to win, 8 things that can happen. Makes sense? Remember, we're not doing odds. Odds here would be 1 over 7 or 1 to 7. All right. Okay, so now we have to find the probability of even. Well, even, how many even numbers are there? 2, 4, 6, 8. There's 4 of them. So remember, probability is how many ways to win, or how many favorable outcomes over all the outcomes. There's eight total outcomes. There's 4 of them that are winners. There's your other fraction. Hey, check it out. We already have common denominator. This will occur if we play 1 game, 1 turn. All right, and then the formula just simply says add those two together. So 1 plus 4 is 5, so we get 5 over 8. Now remember the first day that we did probability, I said let's change everything to percents to make more sense. And I'll just say, take a look at this and you kind of see why I have you do that, right? 5 over 8, that doesn't give you a great feel for what the percent is. If you were to convert this to a percent, it would be 62.5%. So 62.5%, hey, that's better than 50-50, right? Or 50%. So probability of this is not extremely high, but it's high. All right. And by the way, no, you don't need to convert any homework problem into a percent. You can leave them as a fraction. Now, the fraction needs to be reduced. Let's do another example. All right. So this one is going to be wordy, no picture. It looks complicated, ends up being pretty simple. Okay, so let's say we're choosing a car at random. The probability that a randomly chosen car is green is apparently 0.15. Now, they chose not to write that as a fraction. They chose to write that as a decimal. They could have also written it as percent if they wanted to. So that's 15%, by the way, 0.15. And the probability that the car is red is 0.25 or 25%. So let's see, there's a 15% probability that a randomly chosen car is green, and then a randomly chosen car is red is 25% or 0.25. Now, we're not going to consider that the car could be both red or green. So apparently they're just solid colors. So if you choose solid colored cars at random, right, they can't be both red and green. So this once again is a mutually exclusive event. So we use our formula. And yes, once again, I will write the words in there. So let's see, the probability of green or red is the probability of green plus the probability of red. Okay, so let's do it one at a time. What's the probability of green? Well, this one's easy. It already tells us. It literally tells us. It's the first sentence there. The probability that a card randomly chosen is green is 0.15, right? And then if it's red, it's 0.25. What does it say to do? It says to add those two numbers together. 0.15 plus 0.25 is 0.4. If we were to write that as a fraction, 4/10 reduced to fifths. Let's see, as a percent, that would be 40%. So what's the probability that a card chosen at random is red or green? It's about 40%, or 2/5, or 0.4, or 4/10. Okay? So a little bit less than half, right? 50% chance, a little bit less than half, because there's white cars, there's black cars, there's silver cars. I'll leave off any, blue cars, obviously. Okay. One more example? Okay, let's do one more, maybe 2 more. So here we go. What's the probability of spinning purple or yellow? And remember, this is going to be 1 game, 1 turn, right? If we were to say 2 turns, you could do both of those. But in 1 turn, you can't be both purple and yellow, right? So this is clearly a mutually exclusive event. Why am I making a big deal about this? Because eventually, right? We're going to get the other one, events that can occur at the same time. We're going to get a different formula. All right. Eventually, semester final, I'm going to give you a probability that you'll have to figure out whether it's mutually exclusive or not, and then you'll have to choose the right formula. But this is definitely mutually exclusive. These are two events that cannot occur at the same time. You can't be both purple and yellow. Okay, so what probability that you're purple or yellow? There are the words there. Most students skip this step here in blue, but I do want you to realize this is how it should be written. All right, so we need to do probability of purple plus a probability of yellow. So how about purple? How many purple numbers are there? There are 2. How many total numbers are there? There are 8. Remember, we're doing probability, not odds. We get 2 over 8, or 1/4. I would recommend you not reduce to the very end. You'll see why here in a second. How about the probability of yellow? Oh yeah, probability of yellow. Notice if we leave it this way, we already have common denominators. We can add them. And you're like, well, if I reduce those, I still would have. But yeah, but let's just say it wasn't yellow. It was I don't know, probability of purple, of yellow, or a 3, right? I'm sorry, a yellow or a 4. Right, and then the 4, there's only one of those. You'd get 1 over 8, so that one wouldn't be reduced. Bottom line here is let's do all the fraction reduction as the very last step. Okay, so what's the formula say to do? It says to add the 2 together. Okay, so probability of purple or yellow would be 2/8. That's purple. 2/8, that's yellow. 2 plus 2 is 4. So we get 4/8, a half, 50%, right? Well, I mean, that's a pretty good game there. You're likely to, half the time you win, half the time you lose. All right, one last one. What's the probability of red or yellow? Red or yellow? Red or yellow? Now you're going to see why I don't want you to reduce. Red or yellow? So let's see. Can you get a red and yellow at the same time in one turn? The answer is no. You would need 2 turns to get that. We'll see that tomorrow or Friday. Okay, so this is mutually exclusive. I'm going to use the mutually exclusive formula. So it says the 2 events are red or yellow, red or yellow, red or yellow. So what's the probability of red? You guys are already jumping to the answer, aren't you? Probability of red is 1 over 8. The probability of yellow, 2 over 8. If I were to reduce the yellow one to 1/4, then I would be adding 1/8 and 1/4. I'd have to get a common denominator. Now you can see why it's probably best to not reduce the fraction until the very end. All right, 1 plus 2 is 3/8, and that is fully reduced. And let's see, 3/8 would be about 38%, about 38%. Okay, so not very likely, but not unlikely. There's no definition of what is very or a little bit or a lot likely or unlikely. Those are just basic descriptive words. All right, I think you guys can do one by yourself. All right, so this is a mutually exclusive event, so go ahead and answer this one. This is question 2 on the Google Forms. Tell me the probability. You can leave it as a fraction. How'd you do? Okay, so you can't get an odd or a 2, right? They can't happen at the same time. 2 is not odd. Odd is not a 2. All right, so the probability of A or B, the 2 events are odd or a 2. All right, odd. How many odd numbers are there? 1, 3, 5, 7. There's 4 of those, right? And how many 2s are there? There's only one of those. 4 plus 1 is 5/8. Okay, did you get it? All right, cool. Okay, so one thing I want to just highlight, because eventually you're going to be given a scenario, not today, but eventually you're going to be given a scenario. You're going to have to figure out whether it's mutually exclusive or not. And if it's not, they're going to use a different formula. So it would be good for us to look at some examples and just determine, are they mutually exclusive or not? So here's the scenario. You take a test, right? I don't care, math test, history test, whatever. What is the probability that you pass or fail? Right? Is that mutually exclusive or not? Well, remember, mutually events are events that cannot happen at the same time. Can you both pass and fail a test? Well, the answer is you can't do that. Therefore, they are mutually exclusive. Now, this is one of those, if it's yes, it's no, and if it's no, it's yes, so I understand it's a little confusing. You're trying to determine, can these events happen at the same time, right? Therefore, if they can happen at the same time, no, it's not mutually exclusive. But if in red there, if they cannot happen at the same time, they are mutually exclusive. So you're determining, is it mutually exclusive? And fully understand that this is slightly confusing in the wordage. Remember, this is one of those no, yes, yes, no ones. So if they can't happen at the same time, then yes, it is mutually exclusive. And you can't both pass and fail, therefore, yes, this particular scenario, the probability of passing or failing, is mutually exclusive. So we would use the formula for that. Now, we're not going to actually do a calculation here. It's just determining whether or not the scenario is mutually exclusive. And yes, why is it mutually exclusive? Because you can't both pass and fail at the same time. All right, so you take a test. What's the probability you score less than a 9? I don't know how many points this is out of. Less than a 9 or more than a 6. Right? Is it possible for you to do both of those? If the answer is yes, then it's not mutually exclusive. If the answer is no, you can't do both of those at the same time, then the answer is it is mutually exclusive. Confusing? Yeah, absolutely. All right, so let's see. Probability you score less than a 9 or more than a 6. Can you do both of those at the same time? The answer is you certainly can. An 8. If you score an 8 on this test, you're less than 9 but more than 6. So here's an example of a scenario where you can do both of these at the same time. So this is not mutually exclusive. It's the only ones that are mutually exclusive are ones where you cannot do the scenario at the same time. In other words, meet the requirements for the probability of both things at the same time. All right, catching on? All right, we're going to flip 2 coins. It doesn't matter whether you flip 1 coin twice or 2 coins at the same time. It's the same basic game. All right, so 2 coins are tossed. 2 coins are tossed. That's the game. What's the probability you toss 2 heads or 2 tails? 2 heads or 2 tails. Can you get, at the same time, 2 heads or 2 tails? Well, I can certainly get 2 heads at the same time. I can certainly get 2 tails at the same time, but can you get both 2 heads and 2 tails? The answer is no, right? You cannot get both those. Therefore, this is a mutually exclusive event. Now, careful for those of you that your head is spinning right there. Like I said, a couple times now, this is one of those questions where if the answer is no, then the answer is yes. Or if the answer is yes, then the answer is no. And by that I mean we're determining whether things are mutually exclusive. So in red there, for those of you that are still confused, is what I would concentrate on. These are things that cannot happen at the same time. Are these things 2 events that cannot happen at the same time? The answer is yes. Maybe that's easier to understand. Here's another one. Same game. All right, what's the event? So the events are the probability that when you toss 2 dice, right? The sum is 5, or a 5 shows on 1 cube. The sum is 5. And one of the die is a 5. One dice is 5, and the sum is 5. Can these happen, or can these not happen at the same time? Well, let's see. If the sum is 5, that means it's either a 1 and a 4, or 4 and a 1, or 2 and a 3, or 3 and a 2. Well, if that occurs, then there's no 5, right? One die has to be a 5 for this to happen, right? So the probability that the sum is 5 or a 5 shows those are 2 things that cannot happen at the same time. So these are, all right, hopefully you're not confused. All right, try this one. So the game is 2 dice are tossed. The probability that each die shows the same number or the sum is 8. So you tell me, answer in Google Forms. Next question. This is a yes or no question. Is this a mutually exclusive event? All right, so are these things that cannot happen at the same time? Could you get both of those at the same time? Well, the answer is I sure can. If both number cubes have a 4 on them, well, then they have the same number, 4, and their sum is 8. So this is a game that can happen at the same time. So these are not mutually exclusive. They are not mutually exclusive, right? This is the one that we'll do on Friday. Okay, so here's what I want you to do. I've got you 2 examples right here, right? I want you to determine, first off, is it mutually exclusive? If the scenario is mutually exclusive, then I want you to calculate the probability. If it's not, well, then you can't calculate the probability until I give you the class on Friday. So here's two examples. I'm not going to tell you which is which. Figure out if it's mutually exclusive. And if it is mutually exclusive, calculate the probability. Make sense? All right, go for it. How'd you do? All right, let's see. First example there, you pick a number from 1 to 10. So I'm just randomly picking a number from 1 to 10. So the probability that you pick an even number or a number greater than 8. Well, how many even numbers are bigger than 8, right, that are between 1 and 10? Well, 10 is bigger than 8, and it's also even. So I could do both of these at the same time if I choose 10. So these are not mutually exclusive. We'll have to figure that formula out on Friday. Second one, 2 dice are tossed. All right, the probability that each die shows the same number. So that means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. And the sum is 7. Could those happen at the same time? Right? Well, if I'm a 1, 1, or a 2, 2, or 3, 3, 4, 4, 5, 5, or 6, 6, my sum is not 7. Right? My sum is what? A 1, 1 would be a 2 2 would be a 4, 3, 3 would be a 6, 4, 4 would be an 8, 5, 5, 10, 6, 6, 12. So my sum could never be 7. So if I toss 2 dice, all right, there is no way that both of these could happen at the same time. These are mutually exclusive. So I can do this calculation. So probability the same. So let's see. How many are the same? There's a 1, 1, or a 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. There are 6 that are the same, right? So 6 out of 36. Remember, when you toss 2, there's 36 things that can happen. Remember that? What's the probability that you get a 7? So how many ways to get a 7? Let's see. 1 and 6, or 6 and 1. 2 and 5, or 5 and 2. 3 and 4, or 4 and 3. Those are the only ways to get a 7. That's 6 different ways. 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. So there's 6 different ways. Since they're mutually exclusive, we add those together. We get, what, 12 out of 36, which reduces to 1/3, or 33%, approximately 33% probability. Okay, well, there you go. Oh, and by the way, that's it for today. All right. The homework tonight is, it's not incredibly challenging, right? If you do run into any problems, please send me an email. I'll be more than happy to give you assistance. So have a great day, and I'll see you guys on Friday.